Good afternoon. We are going to learn about how to write compositions. These are notes for Chapter 3, Section 2, Part B. A was the previous one, which was translations. So compositions, here we go. Definition of a composition of rigid motions is a transformation with two or more rigid motions. The second rigid motion is performed on the image of the first rigid motion. So you have the original, the first rigid motion, and then the second. It goes in sequence. A small circle separates the two motions. And this is the part that you have to really think about. The second action on the motions is done first. And then the first action shown is done to the result. Okay, so let's look at that. So interpret the composition. So here's actually a composition. See this small circle? And what you need to remember is that the first thing you do to the triangle is actually the second in the expression, which is a translation. And then the second thing that you do after you've translated the figure is you do the reflection across line M. Okay, so when it says interpret the composition, it means write out what it says. So here's what it says. Translate triangle ABC, left -2 units, and up +5 units. And the second part is you're going to reflect triangle A prime, B prime, C prime, which was the result of the first one, across line M. And the resulting figure would be triangle A double prime, B double prime, C double prime. That is your interpretation. All right, so sometimes when you have a composition, you can actually write it as a single transformation. This works if you have a translation and a translation. So what you do is you take the horizontal translation, which is the first one in each vector, that's your x, and you put them together. So I have a +1 plus a 3, and that equals 4. Then you do the same to the vertical, or the y. The y is the second term in the vector. So we take a -1 first, and then we subtract 2 from that, and we get -3. So our combined translation vector has a 4 in the x position and a -3 in the y position. So we're basically taking those two vectors and adding them together. Pretty straightforward, I think. Okay, flip the page. Theorem 3.1. A translation is a composition of reflections across two parallel lines. Now remember, this is a theorem, so it's a relationship that's not the definition. It's another relationship. So a translation is a composition of reflections across two parallel lines. The distance between the pre-image and the final image is twice the distance between the two reflection lines. So here's an illustration of that. You have triangle ABC, which is reflected across line M, where it becomes A prime, B prime, C prime, and then it's reflected across line N, A double prime, C double prime, B double prime. What you notice is once you've reflected it over two parallel lines, the original shape and the result shape have the same orientation. They are not twisted, they are facing the same direction, just like a translation. So what are they talking about with the twice thing? Well, if M and N are the lines of reflection, And you can see the little arrows here, but let's add our own. We know that these are parallel to each other. D is the distance in between them. And what the theorem says is if you draw a line from C to C double prime, that line will have the length of 2 times distance D. So here they wrote it as a composition here. Reflect across line M, reflect across line N, ABC becomes A double prime, B double prime, C double prime. And it's double prime because you've done 2 actions instead of 1. Okay, other information. Remember, both reflection lines are parallel to each other. Both reflection lines are perpendicular to the line containing the pre-image and its corresponding image points. So, perpendicular would be here, 90 degrees between both of the lines of reflection and the line that joins C and C double prime, which is the case in a reflection. Okay, so let's do an example. Given 3 points, A, B, C, what composition, so we're looking for composition, of rigid motion represents those moves? Okay, so what we're going to do is A to B, and then we'll do B to C. Okay, so for A to B, let's rewrite these. We've got A, which is -1, -5. We've got B, which is 2, 4. So if we take the x's and put them together, I take a -1, add it to my x value, and that will give me a 2. Solving for that, x must be a change of 3. Okay, let's do the y's now. -5 plus a y value equals 4, which means y has to be 9. So there is a way to figure it out besides counting on your fingers. So the resulting vector between A and B is the vector 3, 3, 9. All right. So then we're going to go B to C. And let's just write these as vectors. B is 2, 4. C is 5, 10. We're going to do the same thing, break it into its horizontal and vertical motions. So we'll start with horizontal. 2 being added to my x gave me a 5. So x must have been 3. Now the y's. 4 was added to y, and that gave me a 10. So y would be a 6. So the vector representing that motion is 3 in the x, 6 in the y. Now, we're supposed to write this as a composition, which means we have to write it with 2 parts. Remember that the first action goes second in the sequence. So we have a translation. The second one is the first, 3, 6. And then the first translation was 3, 9. So if they ask you for a composition, that's what they're looking for, is 2 different translation vectors. If they're asking you for one single translation, you would first find the composition, and then you would simply add the x's, add the y's. It would be a translation of the vectors 6 and then 15. So you kind of have to read the directions and see what they're looking for, whether it's one single translation or 2. Again, the hardest part to remember is the first translation goes second, and the second translation goes first. All right, that is it for this afternoon. Thank you. Have a good afternoon.